We don't have those really long standard algorithm problems. Starting today, we're going to multiply because we need to do it to solve a problem. Okay? This is a quick little warm-up activity that you haven't seen before. Now, don't look at it. Put your pencil down. Don't write anything. I mean, you can write your name. But I want to ask you a question. Think about it. If I multiply times a number that's less than 1, will my answer be larger or smaller than what I started with? I'm going to repeat it. If I multiply times a number that's less than 1, will my answer be larger or smaller than the one I started with?
Smaller.
Smaller. If I multiply times 1, my number will be the same as the one I started with, right? So less than 1 means that it's going to be less than what I started with. Now, each of these second factors is less than 1, isn't it? Some of them are way less than 1. If I start with 30 and multiply it times 1/10, what do you think my answer is going to be?
3.
3. 1/10 of 30 is 3. So there's a little trick to this if your first factor has a 0 on the end. It's kind of like dividing. Now how do I know what to divide by? Well, this is 1/100th. How many zeros on 100? 2. So how many could I cross off? You want to keep going and see if you can do this? Okay. What about 1,000th? How many times do you think I'm going to cross off a 0? 3 times. Now this works because of that wonderful concept called powers of 10. It won't work if you've got anything other than 100th, 1,000th, or 1/10. Say you had 2,000ths, it's not going to be that simple. Okay? All right, so go ahead and see if you can complete the rest of these, and I will pull a stick for someone to come up and write the first column and the second column. I don't think I did either. Here are the answers to that page. With the help of 5th graders writing them. Okay, so I'm going to do some skipping. Did you notice? I want to skip to here. Okay. And let's go ahead and fill in these measurements. How many inches are in 1 foot? 12. So I think you can figure out the rest of these, right? How many meters is 1 centimeter? 100 centimeters.
1 meter.
Okay, go ahead and finish those and I'll pull sticks. All right. Today, listen carefully. Today we are working with measurement conversions. The first thing I'm going to teach you is a strategy. Because we already know a lot of the answers that we're going to figure out, especially the 2 on this page. So skip down to problem 1. I need you to sit down on your chair correctly, please. Scoot your chair up. There you go. All right, so the first question is, how many days are in 3 weeks?
7.
Somebody tell me the answer.
21.
21. Okay, we got the answer out of the way. Now for the strategy. Okay? The first thing I have to do is figure out, because this right here is not part of my problem, figure out what 1 unit is. Now there's a trick. 1 unit always starts with the number 1, and it's always the unit of measurement that you start with. So 1 unit, what do you think it is, boys and girls? 1 week. Now remember, I'm teaching you a strategy, and it will make sense here in a couple problems, okay? All right, so I'm going to do 3 copies of 1 week. All right? Now, Kaden, how many days are in 1 week?
7.
So that's where I write 7 days. 3 copies of 7 days equals what, boys and girls?
21 minutes.
21 days.
7, 15, 21.
Okay, now, like I said, it's a strategy. It works the same for hours and minutes. Let's just get the answer out of the way right now. How many minutes in 3 hours?
180.
180. Okay, that's done. Now the strategy. 3 hours equals 3 copies of 1 unit. By the way, 1 unit's going to start with the number 1. And it's going to be the same unit of measurement I started with. So 1 what?
Hour.
Hour. Okay. Now, 3 copies of how many minutes in an hour?
60.
60 minutes. You'll see a lot of abbreviations. So that's where I came up with 180 minutes. Okay? So that's the strategy. Now let's figure out some problems that we might not know the answer to. Okay? So turn it over to problem 2. There's several problem 2s. I don't know why it's just called problem 2. There's 6 of them. Okay? So let's talk about the metric system. Now I laid down a meter stick next to some yardsticks, or next to some rulers, and we'll talk about that later. But a meter stick has how many centimeters in it? Do you remember?
100.
100. And in the metric system, are you listening? For 5th grade, that's the only 100 we use for the metric system. Okay? So let's use the strategy we just learned. 1 5/100 copies of 1 unit. What's 1 unit?
Oh, yours is different than mine. Yeah. Ours is all funky.
Oh, it's not lined up correctly, is it?
Someone
Sorry
hit
about that. That was me.
Someone hit return.
No, my text box wasn't big enough. I just needed to drag it out a little wider. I'll show you here in a minute. So what is 1 unit? Because I've been waiting for you to say it. 1 what?
Meter.
1 meter. Where did I get the meter? Right here. That's what I started with. Okay? Then I have 1 5/100 copies of how many centimeters in a meter?
100.
100. So 100 centimeters. Now this is why I love the metric system. 1, 2 decimal hops. So my answer is how many centimeters? 105. Okay? The decimal hop in the metric system makes life easy. Okay, let's try it on the next one, but instead of centimeters, what is it?
Meter.
So 1 5/100 meters times 1 unit. What is 1 unit?
Meter.
1 meter. 1 5/100 times how many millimeters are in a meter?
1,000.
Very good, block 3. So my label here is 2 small m's, okay? So if I do the decimal hop, and I'm going to rewrite this so I don't run into my multiplication sign, watch me. 1, 2, 3, fill in with how many zeros? So I have 1,050 millimeters. Okay, now how is the decimal hop different from the standard algorithm we've been using? How is it different? Any answers? Anybody have an idea? I know you need to listen to the question. How is the decimal hop different from the standard algorithm that we've been using? Corbin, what do you think?
It's faster.
Way faster. Okay. What else, Rustin?
We don't
We-
don't multiply down.
We don't have a bunch of steps, do we? It's quite simple. Okay. Do I have to look back and count my place values?
No, ma'am.
No. So that's nice, isn't it?
Yes, ma'am.
When I'm done with the decimal hop, I'm finished with the problem. Now imagine if you were in the class, the first class I had when I taught 5th grade. The directions don't say to teach the students the decimal hop, so I didn't teach the students the decimal hop. Can you imagine trying to do this without it? You would have a place value chart and you would be sliding digits across the place value chart. So aren't you so glad I didn't follow the rules?
Yeah.
I know. Let's look at the next one.
Wait.
You need that decimal hop to make your life easier. So I've got 9/100 copies of 1 unit. Jesus, what is 1 unit?
1 meter.
1 meter. Okay. How many centimeters, Brian, in 1 meter?
100.
100 centimeters in 1 meter. Okay. So if I do the decimal hop on this, watch me. 1, 2. What's my answer? So in 9/100 of a meter, you have 9 centimeters.
Wow.
I know. I love the metric system. It's just so easy to work with. What about over here? What's different? Is my unit different than I start with? No. Millimeters is different. So how about Jared? How many millimeters in 1 meter?
100.
Well, that's what centimeters is.
Oh, 1,000.
Let him think. So 1,000 millimeters. If I'm going to hop the decimal on this, 1, 2, 3. How many zeros do I fill in with?
90.
1 0. Okay? Now, boys and girls, you cannot forget the labels. It's incorrect without the labels. I didn't go back and write the answer at the top because on the problem set, we don't even have this part right here. I probably just need to change this. Okay? All right, so let's go on. These are still centimeters and meters. Okay? So what I want you to do is I want you to try and complete these two on your own, and then we'll talk about them. I'm going to push pause. Go ahead, Alondra. So what's 1 unit?
1 millimeter.
1 meter.
Meter.
Right. How many millimeters in a meter?
1,000.
Good. If I take 2/10 times 1,000, how many decimal hops do I need?
3.
3. So my answer is
200 millimeters.
200 millimeters. Okay, let's go to the next one. These are not the metric system. Well, the first one is. Here's what it would look like if there were word problems, okay? So here's a habit I want you to get into. A crate of apples weighs 5.7 kilograms. Convert the weight to grams. I want you to identify your 2 units of measurement, okay? And underline them or highlight them. So go ahead and do that now.
Very easy.
So for 5.7 kilograms, what would 1 unit be?
1 kg.
1 kg. 1 kilogram, okay? That's the abbreviation for kilogram. And then, how many grams do you think are in a kilogram?
100.
What? No, that only
10,000.
1,000. Everything in 5th grade is 1,000 except centimeters. Did you hear what I just said?
Yep.
Metric system conversions, we only work with 100 and 1,000 in 5th grade. The only 100 we have is centimeters. So if you run across another word, and how do I know it's a metric system? Because of the prefix. What's the prefix?
Kilo.
Okay? You're also going to have centa and milla. Okay? All right, so how do I do this problem? 1, 2, 3. How many zeros do I fill in with? So 5,700 grams. Okay, now the metric system right here, this one, is so much easier than customary units of measurement. Now, what I mean by customary is United States. Okay? We're the only ones, I don't know this for sure, but I've heard that there aren't very many countries in the world that use the customary units of measurement. Most people have switched over to the metric system because it's so simple. Okay? So if I look at this first number, 56 and 75 hundredths, I've got to take it times 1 unit. What do you think LBS stands for? Does anybody know? Pounds. And so I'm going to take it times 1 pound. Now, I always wondered, why didn't they just make it PD for pound? Or something like that, okay? But I have the answer.
Is it because,
Jesus is going to tell us. Or Mia. Or Jared. Or Brian.
What?
Or Amy.
I don't know the answer.
I didn't say your name. Where do you think they came up with LB for pound? Yanelli, do you have an idea? Think of your native language.
Oh, Spanish.
Fernando, how do you say pound in Spanish?
Libras.
Oh, that makes perfect sense, doesn't it?
Oh, yeah.
So the Spanish word for pound is where we come up with LB. And I always wondered, but I never knew. Would you like to tell me would you like to know who figured it out?
Who?
Angel Rivera.
My brother?
Mm-hmm. He said, hey, Mrs. Lewis, I wonder if that comes from the Spanish word for pound. And I said, I think it does. Okay, so how many ounces are in 1 pound? That's the question of the day. Anybody know?
10,000.
Doesn't make any sense. So you just pick a random number.
10,000.
How about 16?
What?
Yeah, I know.
That's why there's a 16-ounce cup and there's a 20-ounce.
Very good, very good. So if you're going to get coffee at the Quick Trip, you might want to get a 16-ounce, which is,
1 pound.
well, sort of. That's how much it
Depends what you put
weighs.
into it.
Right. Okay, so here's my thoughts on it. There's really only one way to solve this problem.
Round.
No. Because it would be nice if we could, but we need to be exact. So we have to use a standard algorithm. Now, when I use a standard algorithm, do I have to pay attention to the decimal place value that I started with?
Yes.
Yes, I do. So the only way to solve this problem is to multiply, boys and girls. So go ahead and get busy multiplying.
Filing.
Shh.
I don't have enough room. Too bad. So sad.
I'm running into that same problem too. So what did I decide to do?
Figure it
Right, small. So since I'm paying attention to the decimal place value, I have to place my decimal as soon as I finish the standard algorithm. Now, last week we talked a little bit about this because you're looking at this number and you already know that those 2 zeros don't have to be written, do they? And so sometimes what kids do is they know that the answer is 908 because they, take off the 2 zeros, and then they accidentally get confused and then place the decimal. Now you have to remember, place the decimal before you take off zeros. You know what I mean by take off zeros, because they don't change the value of the number. So the answer to this is 908, what? Ounces. Ounces. All right. So that's the lesson for the day, and we're going to practice now
Practice what?
on the problem. Okay, so taking a look at the problem set, This is fun. I think it's kind of a nice break from the standard algorithm. Okay, the first one they did weeks to days. And you can just look at it. It's pretty much the same strategy we just used. What? We're all hungry. Okay, so let's take a look at B. Remember what I wanted you to get in the habit of underlining? Your 2 units of measurement. So years to days is what we're working with on B. Okay, so 1 unit would be how many years? 1 year. 4 copies of 1 year. So how many days are in a year? 365. Okay. So to solve this problem, what do I have to multiply?
365 times 4.
Okay, go ahead and do that and see if we get the same answer. Okay, and was there a decimal place value in my original number? So I don't have to worry about placing the decimal. Okay, let's go down and look at C. Okay, it says convert meters to centimeters, and it looks like they already wrote our labels on there for us. So I'm starting with 9 2/10 meters. And how much would 1 unit be? 1 what? 1 meter. 9 2/10 meters. How many centimeters are in a meter? 100. So now on this one, what's my strategy for solving it? Standard algorithm or decimal hop? So how many place values? 2. Fill in with? So it's 920 centimeters. All right. And finally we get to D where we have to write it ourselves. What are we converting to here?
Yards and feet.
Okay, so I'm going to start with placing my 3 equal signs. Okay. And this is what I showed the earlier classes. If you don't know how many feet are in a yard, okay, you could use your tools to help you. Now, what kind of tools could you use for feet and yards? Yardstick would be perfect, wouldn't it?
Yes.
But I only have a meter stick. Now, I do know that meters are close to yards. Do you know which one's longer? You know, I don't know. I think we're just going to have to find out. Okay? So, and I've got to figure out feet, right? So look at me. What could I use this 1 foot? We've used it many times. A ruler, okay? And I'm just going to lay it next to my meter stick. And then I'm going to have to use my best judgment, a little bit of logic here, to decide. So I've laid 3 rulers next to this meter stick. And if I lay 4, it's more than a yard and it's quite a bit more, isn't it? So which one makes more sense, 3 feet or 4 feet? 3. It just so happens that there are 3 feet in a yard, okay? And so that's what you need to know to solve this problem. But using a yardstick would tell you immediately, because a yardstick will show you 36 inches. So now what do I do? 5.7 copies of 1 unit. What is 1 unit?
1 yard.
1 yard. It's quite simple. Cooper, you need to be writing, please. It's almost lunchtime. We can make it. I had to drink coffee to fill up my stomach. Okay, so how many feet did we say were in a yard?
3.
3. And notice there are a lot of abbreviations. Now, how do I solve this problem? Standard algorithm, do I have to pay attention to the decimal place value?
Yes.
Yes. So what place value did I start with? Tenths. Go ahead and multiply. So the answer to how many feet are in 5.7 yards? 17 and 1/10 feet. Now something I wanted to show you. This is kind of clever with the abbreviations. If you get confused, here's something you can look at. The first two labels match and the second two labels match. Okay? So that can help you if you get confused all of a sudden. Take a look at this next one. Is this metric or customary? Kilograms to grams.
Metric.
How do you know?
Because you said that it was earlier.
It's the prefix, right? It's the prefix, kilo.
Yes.
So, first step, write your 3 equal signs. Okay, so what is one unit going to be? One what, Mia?
1
1 kilogram, which is kg, right?
Yep.
And I've got 6 8/100 copies of that. This is kind of fun, isn't it?
Yep.
Okay, and then how many grams do you think are in a kilogram, class? Please don't tell me 100. 1,000. Kilo means 1,000, by the way. We talked about that earlier in the year, but you might have forgotten.
Oh, I remember. You gave us a chart.
I know. Okay, so now to multiply this, standard algorithm or decimal hop? Decimal hop. I'm going to rewrite it. How many place values?
3.
How many zeros do I fill in with? What's my label? Kilograms, kilograms, grams, grams. All right, next one, pounds to ounces. Customary or metric? I don't see kilo, centi, or milli. Customary. So you have to know how many ounces are in 1 pound. Who remembers? It's like a random number. 16. Awesome. So 1 unit. Cooper, are you writing this? What's 1 unit, boys and girls?
1 pound.
1 pound, 1 lb. Makes perfect sense now. And you just told me there are 16 ounces in a pound. Since this is customary, do I have to pay attention to what decimal place value I started with?
Yes.
Yes, it's tenths. So what's the best way to solve this problem here? Standard algorithm. See if you get the same thing I get. What is my label? OZ. Now, remember, you don't have to write the last decimal, but you do have to, last zero, but you do have to leave it on there to place your decimal. Okay? All right, now go back to the front of the page. These are a little bit different. These are like mini word problems. So B is talking about a gorilla.
Yeah, gorilla.
And I want you to tell me what to underline in this little mini word problem, okay? A small female gorilla weighs 68 kilograms. How much does she weigh in grams?
Grams.
Good. So what will I write first? 68 kilograms equals, equals, equals. All right, what is 1 unit, Jarrett?
1 kilogram.
1 kilogram. How many grams in a kilogram, Justin?
100,000.
1,000. Don't answer 100 unless it's centimeters, okay? Do we need to write this on our hand before we take the math test tomorrow?
No. Yes.
I'm just kidding. Okay, so now to solve this problem, how do you do it?
You just do the decimal hop.
Okay,
Same
and where's my
along.
decimal to start with on 68?
Out of the 8.
1, 2, 3. So does that make sense? 68 times 1,000
68,000.
equals 68,000 grams.
Wait, one more minute until we know gorilla that weigh that much with itself.
Okay, so what I'm going to have to do, let's see. The height of a man is 1.7 meters. What is his height in centimeters? So what 2 words to underline, Tucker? Meters and centimeters. So I'm going from meters to centimeters. So 1.7 meters equals. What is 1 unit? 1 meter. 1.7 times 1 meter equals 1.7 times, how many centimeters in a meter, Halen? No, that's feet and yards. This is the metric system. So it's either going to be 100 or 1,000. How many centimeters in a meter? 100. 100. And is this the class I said, well, you know, a century is 100 years. So that kind of goes with centimeter, doesn't it? So when I multiply 1.7 times 100, how many zeros will I need to fill in with? 1 0. So it's 170 centimeters. You know, that makes sense because this is a meter stick. And if I add 70 centimeters onto this meter stick, where am I about right here? Just kind of guessing. 70 would be about there. Is that about how tall a man might be?
But
Yeah.
sometimes.
Yeah.
Wow.
Sometimes. Okay, D. The capacity of a syringe. Now they're trying to get you to stop right there and say you don't know how to do it. Because of capacity and syringe. Syringe. Okay? Don't let those words mess you up. That's not what the problem's about.
The syringe is just like those things that they give you shot.
Right. Okay? Or you might get medicine for a baby and pull it up out of the bottle in a syringe and then stick it in their mouth. Anybody ever seen that?
Yes.
Yeah. Okay? So it says the capacity is 800 liters. Convert this to milliliters. So what are my 2 words?
Liters and milliliters.
Liters and milliliters. So we know that we've got 800 liters. Capital L is your abbreviation for liters. Has to be a capital. Okay, what is 1 unit?
1 liter.
1 liter. So we've got 800 times 1 capital L. Now take a stab at it. That means take a guess. How many milliliters do you think are in a liter?
1,000.
Very good. So we've got 800 times 1,000 ml. Now look how I did my abbreviation for that. Did I stay with the capital L?
Yeah.
I did. So milliliters is lowercase m, capital L. All right. Now how do I solve this? 800 times 1,000. So 1, 2, 3,
Add
1 0. My answer is
80 milliliters.
80 milliliters. Okay, how you doing? Just 2 more and then an exit ticket. I think you can handle it.
Yay.
So let me read this little mini word problem. A coyote weighs 11.3 pounds. Convert the coyote's weight to ounces. So what are my two words?
Pounds and ounces.
Pounds and ounces. This is not the metric system. So I suspect we'll have standard algorithm here. If I have standard algorithm here, okay, so I have to figure out, ooh, I'm back on red. I don't really want red today. Kind of in a blue mood. 11.3 LBS equals. Right. Now, 11.3 times 1 unit. What's 1 unit?
1 pound.
1 LB. And it has to be a lowercase l. Now, 11.3 times how many ounces?
16.
Very good. Good memory. So this is where the standard algorithm comes in. Do I have to pay attention to my place value?
Yes.
Yes, I do. It's not metric system, so place value certainly counts here when I write my final answer. Okay, check my multiplication. It's been a couple days since I had to do any work around here.
Really?
Yeah.
Okay. I'm at the end. How did you get 6, 7, 8?
Because I regrouped 3 times 6 is 18. Add the 1. Okay, so 180 and 8/10 ounces. You already had that, didn't you? So Channing got a pound and ounce question on the math assessment. Did anybody else?
I got
You
it
did?
on third.
Well, yes, you did. Okay, let's look it up. An alligator is 2.3 yards long. What is the length of the alligator in inches? Okay, now, do you remember the other day when I had to put this meter stick out here?
Yeah.
And then I added some rulers to figure out how many feet were in a meter. And it was how many feet?
3.
3 feet in one what?
One
Yard.
Oh, yeah.
But remember, I didn't have a yardstick, so I had to use a meter stick and find the one that was closest, okay? So if I've got 3 feet, how many inches is that? Quick.
36.
Very good, 36. So I'm going to do 2.3 yards equals. And 1 unit is 1 what, boys and girls?
1 yard.
1 yard, you've got this. And then how many inches? Ooh, look what I forgot to underline. 36 inches. Is this standard algorithm again? Yes, it is. What's my place value I started with?
The 10th.
Thank you. Okay, looks